Life on Mars. On August 7, 1996, report photographers and television camera operators searched into NASA headquarters in Washington, D.C. The crowd focused not on the row of seated scientists in NASA auditorium, but on a small clear plastic box on table in front of them. Inside the box was a velvet pillow, and nestled on it like a crown jewel was a rock from Mars. The Science League announced that they found signs of life inside the meteorite. NASA Administrator Daniel Golding said it was an unbelievable day. He was more accurate than he knew. The rock the research explained had formed 4.5 billion years ago on Mars, where it remained until 16 million years ago, when it was launched into space, probably by the impact of an asteroid. The rock wandered the inner solar system until 13,000 years ago, when it fell to Antarctic. It sat on the ice near Allen Hills until 1984, when snowmobiling jellies scooped it up. Scientists, headed by Daniel McKay of the Johnson Space Center in Houston, found that the rock, called ALH 84001, had a peculiar chemical makeup. It contained a combination of minerals and carbon compounds that on Earth are created by microbes. It also had crystals of magnetic iron oxide, called magnetic, which some bacteria produce. Moreover, Mackay presented to the crowd an electron microscope view of the rock showing chines of globules that bore a striking resemblance to chines that some bacteria form on Earth. We believe that these are inert microfossils from Mars. Mackay said, adding that the evidence wasn't absolute proof of past Martian life, but rather pointers in that direction. Among the last to speak that day was J. Williams Schopf, a University of California at Angeles paleobiologist, who specializes in early Earth fossils. I will show you the oldest evidence of life on this planet. Schopf said to the audience and displayed a slide of a 3.465 billion year old fossil chain of microscope globules that he had found in Australia. These are demonstrably fossils. Schopf said, implying the NASA Martian pictures were not. He closed by quoting the astronomer Carl Sagan. Extraordinary claims require extraordinary evidence. Despite Schopf's note of skepticism, the NASA announcement was trumpeted worldwide. Mars Life rock shows meteorite holds evidence of life on another world, say the New York Times. Fossils from the red planet may prove that we are not alone, declared the Independent of London. Over the past 9 years, science have taken Sagan's word very much to heart. They have scrutinized the Marian meteorite, which is now on view at the Smithsonian National Museum of Natural History. And today few believe that it harbored Martin microbes. The controversy has prompted science to ask how they can know whether some blood, crystalline or chemical oddity is a sign of life, even on Earth. A debate has flared up over saying some of the oldest evidence for life on Earth, include the fossil that showed proudly displayed in 1996. Major questions are at stake in this debate, including how life first evolved on Earth. Some science propose that for the first few 100 million years that life exists. Its bird-like resemblance to life as we know it today. NASA research are taking lessons from the debate about life on Earth to Mars. If goes out planet a new generation of rovers will arrive on Mars within the next decade. This million will incorporate cutting-edge biotechnology designed to detect individual molecules, but made by Martian organisms, either living or long dead. The search for life on Mars has become more urgent thanks, in part to proof by the two rovers now roaming Mars surface and another spaceship that is orbiting the planet. In recent months, they have made a series of astonishing discoveries that once again tempt science to believe that Mars harbors life, or did so in the past. At a February conference in the Netherlands, an audience for Mars expert was surveyed about Martian life. Some 75% of the science say they thought life once existed there. And of them, 25% think that Mars harbors life today. The search for the fossil remains of primitive single celled organisms like bacteria took off in 1953 when Stanley Taylor, an economic geologist at the University of Wisconsin, puzzled over some 2.1 billion year old rocks he had gathered in Ontario, Canada. His glassy black rocks, known as sherd, were loaded with strange microscopic filaments and hollow balls. Working with Harvard paleobotan isn't Elso Bargon. Taylor proposed that his shape we are actually fossil left behind by ancient life forms such as algae. Before Taylor and Bargon's work, few fossils he had been found that prepared the Cambrian period, which began about 5,014 million years ago. Now, the two scientists were positing that life was present much early in the 4.55 billion year history of our planet. How much further back it went remains for later science to discover. In the next decade, paleontologists in Africa found 3 billion year old fossil traces of microscopic bacteria that had lived in massive marine reef. Bacteria can also form what are called biofilms, colonies that grow in thin layers over surface such a rock at the ocean floor. And scientists have found solid evidence for biofilms dating back 3.2 billion years. But at the time of the NASA press conference, the oldest fossil claim belonged to UCLA William Shop, the man who spoke skeptically about NASA finds at the same conference. During the 1960s, 70s, and 80s, Shop had become a leading expert on early life forms, discovering fossils around the world, including 3 billion year-old fossilized bacteria in South Africa. Then in 1987, he and some college report that they had found the 3.465 billion year old microscopic fossil at a site called Warrawoona in the Western Australia outback. The ones he would display at the NASA press conference. The bacteria in the fossil were so sophisticated, Shop says that they indicate life was flourishing at that time, and thus life organic appreciably early than 3.5 billion years ago. Scientists have developed other methods for detecting signs of early life on Earth. One involves measuring different isotopes or atomic forms of carbon. The ratio on the isotopes indicate that the carbon was on a part of a living thing. In 1996, a team of research report that they had found life a signature in rocks from Greenland dating back 383 billion years. The signs of life in Australia and Greenland were remarkably old, especially considering that life probably could not have persisted on Earth for the planet's first few hundreds of millions of years. That because asteroids were bombarding it, boiling the ocean and liking sterilizing the planet surface before about 3.8 billion years ago. The fossil evidence suggests that life emerged soon after our world cooled down. As Shop wrote in his book, Cradle of Life, his 1987 discovery tell us that early evolution proceeded very fast. A quiet start to life on Earth could mean that life could also emerge quickly on other worlds. Like planets circling other stars, or perhaps even other planets or moons in our own solar system. Of this, Mars has long looked the most promising. The surface on Mars today doesn't seem like the sort of place hospitable to life. It is dry and cold, plunging down as far as degrees Fahrenheit. In this atmosphere cannot block ultraviolet radiation from space, which would devastate any known living thing on the surface of the planet. But Mars, which is old ahead, might have been more hospitable in the past. The wilds and dry lake that mark the planet indicate that water once flowed here. When NASA Mackay presented his picture of Martian fossil to the press that day in 1996, one of the million of people who saw them on television was a young British environmental microbiologist named Andrew Stell. He had just earned a PhD at the University of Portsmouth, where he was studying bacterial biofilm that can absorb reactivity from contaminated steel in nuclear factiles. And expressed at microscopic images of microbial state got Mackay's telephone number from directory assistant and called him. I can get you a better picture than that. He said and convinced Mackay to send him pies of the meteorite. Still, analysts were so good that soon he was working for NASA. Ironically, though his work undercut NASA evidence, still discovered that early bacteria has contaminated the Mars meteorite. Biofilms had formed and spread through cracks into its interior, still resulting didn't disprove the Martian fossil outright. It's possible that the meteorite contains both Martian fossil and Antarctic contain, but he weighs the problem is how do you tell the difference? At the same time, other science point out that non-being process on Mars also could have created the globules and managed clumps that NASA scientists had held up as fossil evidence. The controversy has raised a profound question in the minds of many scientists. What does it take to prove the presence of life billions of years ago? Oxford paleontologist Martin Baser borrowed the original Warrawoona fossil from the Natural History Museum in London, and he and Steele and their college have studied the chemistry and structure of the rocks. In 2002, they conclude that it was impossible to say whether the fossils were real. In essentially, subject shop works to the same skepticism that Schopp has expressed about the fossil from Mars. The irony was not lost on, say still. In particular, Schopp had proposed that its fossils were photosynthetic bacteria that capture sunlight in a shallow lawn, but Brazier and Steele and Cook workers conclude that the rocks had formed in hot weather load with metal perhaps around a superheat vent at the bottom of the ocean, hardly the sort of place where some loving microbe could thrive. And microscopic analysis of the rock still says was ambiguous as they demonstrate on day in his lab by shopping a slide from the Warrawoona shared under a microscope right to his computer. What they're looking at there? Some insist there that being caught in a rock. Are we looking alive? Maybe, maybe. You can see how easily you can fool yourself. There's nothing to say that bacteria can't live in this, but there's nothing to say that you are looking at bacteria. Schopp has responded to Steele's criticisms with new research of his own. Analysts his SEMs further, he found that they were made of a form of carbon known as chiron, which would be expect in the remains of bacteria of his critic shop says then they would like to keep the debate alive, but the evidence is overwhelming. The disagreement is typical of the fast-moving field. Geologist Christopher Fedor of George Washington University and geochronologist Martin Whitehouse of the Wesleyan Museum of Natural History have changed the 3.83 billion year or molecular trace of light carbon from Greenland, saying the rock had formed from volcanic lava, which is much too hot the microbes to withstand. Other recent claims also are under assault. A year ago, a demo science made headlines with their report of tiny tunnels in 3 billion-year-old African rocks. The scientists argued that the tunnels were made by ice and bacteria around the time the rock formed, but still points out that bacteria might have dug those tunnels billions of years later. If you date the London Underground that way, say still, you have say it was 5 million years old, because that is how all the rocks are around it. Such debates may seem indecorous, but most scientists are happy to see them unfold. What this will do is get a lot of people to roll up their sleeve and look for more stuff, says meat geologist John Grotzinger. To be sure, the debates are about subtleties in the fossil record, not about the existence of microbes long ago. Even a skeptic like Stills remains fairly confident that microbial microscope, and not even critics have challenged the less from Munich Rosin of the University Copenhagen's Geological Museum, who was found the carbon isotope life a signature in a sample of 3.7 billion year old rock, the oldest undisputed evidence of life on Earth. At stake in this debate is not just the timing of life early evolution, but the path it took. This past September, for example, Michael Tice and Donald Lowe of Stanford University report on 4,016 billion year old mass of microbe preserved in rocks from South Africa. The microbe, they say, carried out photosynthesis but didn't produce oxygen in the process. A small number of bacterial species today do the same. Anoxygenic photosynthesis is called. And Tice and Lowe suggest that much microbes figuring out life early chapter will then scientifically not only agree about history of our planet, it will also guide their search for seeing of life elsewhere in the universe, starting with Mars. But just a few days later, European Science announced that they had detected formaldehyde in the Martian atmosphere. Another compute that on Earth is produced by living things. Shortly thereafter, research at the European Space Agency released images of the Helium's plains, a region along Mars' equator. The texture of the landscape, they argued, shows that the area was a frozen ocean just a few million years ago, not long in geological time. A frozen sea may still be there today, buried under a layer of volcanic dust, while water has yet to be found on Mars' surface. Some research studying Martian gills say that the feathers may have been produced by underground aquifers, suggesting that water and the light from that required water might be hidden. Andrew Steele is on of scientifically designing the next generation of equipment to approach for life of Mars. Untold, he plans to export to Mars a skull of microarray, a glass slide onto which different antibodies are attached. Each antibody recognizes and latches onto a specific molecule, and each due of a particular antibody has been right to glow when it finds its molecular partner.